Hi there. Welcome to my video on the taxonomy of cognitive learning outcomes. My name is Daniel Al-Kabbani and I would like to introduce to you this concept that will help you to find good learning outcomes focused on the cognitive part. So there are also other learning outcomes than only the cognitive learning outcomes, but see my other videos for that. So let's begin. You see, I'm not alone. I brought somebody here with me. So this is Carl, and yeah, with the help of Carl, I want to introduce to you the idea of the taxonomy of cognitive learning outcomes. Okay, now imagine Carl joined a course on the basics of geometry, and we know from the syllabus that one of the contents of the course was the theorem of Pythagoras. So now it's the end of the term and we want to assess Carl and we want to know about his competencies regarding to the theorem of Pythagoras. And now have a look at him. What can you say about his competencies according to the theorem of Pythagoras? You're absolutely right. Nothing. Why is that? It's because a student that knows everything about the theorem of Pythagoras doesn't look different from a student who doesn't know the theorem of Pythagoras at all. So we cannot see it. Therefore, Carl has to do something observable. So maybe the simplest thing would be we could ask him, hey Carl, what is the theorem of Pythagoras? And Carl tells us, okay, it's a squared plus b squared equals c squared. So this is the formula to the theorem of Pythagoras. And yeah, so he did something observable. He can tell it, or maybe he can write it down. It does make a difference, but it's important that we can hear it if he tells it, or we see it when he writes it down, so it's observable for us. Now, when he does that, so he recites the theorem or the formula to the theorem, then we can make the conclusion he's able to remember this equation. You know, we didn't know that before. We just could assume it, but now we know it. He's able to remember it. Not only that he has the knowledge somewhere in his brain, but he's also able to retrieve this knowledge if we ask him. But maybe this is not enough for us. Now let's go one step beyond. Now we could ask him, okay, Carl, a nice equation, but what does that mean? And he starts to explain us what this formula means in his very own words. So imagine it's not just the sentence from the book, the definition from the book that he's just repeating, but it's explained in his very own words. And he starts to explain if you have a right angled triangle, then you will find a certain relation between the lengths of the triangle's legs and something like that. Maybe he makes a little doodle, a little graph to illustrate it. So what do we know now? Now again, he's doing something observable. He explains in his own words, oral or written, it doesn't matter. And from this observable activity, we can make another conclusion. So he understood this equation. He knows what this collection of letters and numbers and mathematical symbols just mean. So this is an understanding on a very basic level. I have to emphasize this. It's not that he understands the complete math behind it, or how to prove this equation or something like that. It's just an understanding what this exact equation means. So the first step, the remembering thing, this could also do a well-trained parrot. You know, he also could tell us the equation to Pythagoras' theorem, but a parrot would not be able to explain what that means, at least not in his own words. Okay, but let's go one step further. So maybe now we want to check if Carl is also able to do something with this equation. So we could give him a task. We give him a right angled triangle, and the lengths of two sides are given, and we asked him to calculate the third leg. And he's able to do that, and we give him some more tasks like this, and he does it very appropriate without making mistakes. Now we know that he's able to calculate the equation. This is again an observable action, and now we can conclude that he's able to apply this equation on a certain kind of problem. So let me emphasize again, this is not a very complex problem. This is also not a real world problem, so that doesn't happen in real life. You do not walk through the city and find a triangle laying on the floor and saying, hey, please calculate my length. This won't happen, but this is very well structured problem. He does exactly know what to do and how to do it. He has just to prove that he's able to do it. So this is also a step of the competence, but you don't have to mix this up. So applying is really focusing on a very very well defined problem here. But if you walk through the town, then something else could happen. For example, you can find something like this. So in Germany we call this a Fachwerkhaus. So this houses with those wooden structures in it. And Karl immediately sees that the structure is forming a right-angled triangle, and based on his knowledge about the theorem of Pythagoras, immediately he starts to talk about how the sides, the lengths of the legs relate to each other in this construction. So what do we know now about Karl's competencies? A colleague at this point in one workshop mentioned, okay, now we know we went too far with Karl. Okay, maybe, but despite of that, we know that he's able to analyze this construction. So now we are in the real world. So he's able to see the real world, a real world scenario in another way. Of course, he was able to see this building before, but now, based on his knowledge, he can make other he sees other things in it, he can go deeper into what he's seeing. So analyzing is also what this level of competency is called. So enough with Karl. What do we see here? So if we plan our courses, of course it's important to think about the content we want to teach. So the content obviously is, in this case, the theorem of Pythagoras. But as you can see, there are very different levels of competence you could achieve with the students here. And remembering the theorem of Pythagoras may be quite easy. But for example, the last step, to analyze some real world scenario based on the theorem of Pythagoras, this is quite harder. And if you want to go there, then you need more time with the students, and then you need other learning activities and other assessments. If you want to have an idea what that means, please watch my video on the constructive alignment. You can also see that thinking about the level of competence is also not enough. Sometimes it's hard to see on which level your students are. So please formulate your learning outcomes in a way that it's directly observable, like here in the blue boxes. So the blue box is how you should formulate your learning outcome. So now let's have a look at the full taxonomy in its completeness. To make clear what taxonomy just means, is just a system to bring, in this case, the levels of learning outcomes in a certain order. So this is what's meant by this name. And this taxonomy is based on Bloom's taxonomy. But the co-workers of Bloom, Anderson and Krathwohl, made a revision from this taxonomy about 2001, and this is now the actual version of this taxonomy. The first 4 levels you just saw in the example with Karl. So there is remember, understand, apply, and analyze. But there are 2 more levels. I just skipped them out in the example because I know you got the idea at this point. The next level would be level 5, evaluate, evaluate, and the last level is create. So that means that you really create some new ideas, some new models, theories, applications for Pythagoras theorem, a generalization of the theorem, or maybe a specification of the theorem, something like that. So you think about something new that nobody ever thought before. When you start to plan your learning outcomes for your course, then think about the content and think about, okay, where do my students come from? Maybe they heard about Pythagoras theorem in the course before, but maybe they only remembered it. They heard this equation and that's it. And they maybe can say it if you ask them, but they not even understood this theorem. Or maybe they already practiced the application, so level 3. So you can easily go to the next level to analyze. So this is the step that you can do. So think where do they come from, but also think where do I want to go with them. But that's not enough. So when you have the idea, okay, I want to go to level 4, analyze, for example, then you have to make this more precise. So choose an observable activity the students can do to prove that they have achieved this level. So observable activities could be for the first level something like describe, identify, label, list, match, memorize, name, recognize, recall, or reproduce. This could be activities that gives you the hint, okay, they are at this level. And there are collections of verbs like those for all 6 levels. You can stop the video here and go through them. I don't read all of them out now. And of course, you will find lists like that in the internet, or if you are joining a course, a workshop from me, or a webinar, then you will also get a collection of possible verbs here. So, how do we formulate a well-defined learning outcome? Usually you need several things to make a good learning outcome. Let's start with an introduction like the students are able. They are able to do what? And then you have to mention several things. So the first thing is what I already said. They are able to do what? So this is a description of the competence, the level of competence they should achieve. Then you can bring in something like by using what, so by using which theory, which model, which equation, or something like that. So this is where the content comes in. So there's almost no learning outcome without mentioning also content. So it's not learning outcome or content. A learning outcome is always with the content. And the best thing would be if you also can say for which purpose. So the relevance. So why should I even do that? Why is this relevant to know that and to have this competence? Let's give an example. So if we have a seminar about communication skills, and then we could say the students are able to analyze a critical communication situation by using the 4 sides model of Friedemann Schulz von Thun in order to clear up mistakes and improve the situation. So this is very clear, well-defined learning outcome because it's directly observable. You can see when the students analyze this, written or oral. You have a focus on a certain content, and the students should know why should they do that. Yeah, okay, that's it. Thank you very much. Let me just emphasize there are more than only cognitive learning outcomes. Watch my other videos to know about that. And if you have any questions or comments, please contact me. So here you find my email address and my website. Thank you.